Hello GED students, it's GED question of the daytime, and today I've got a divisibility problem. So divisibility problems can show up in the first 5 problems on the GED, the ones where you don't get a calculator. Plus they're important for understanding fractions. If you're trying to learn fractions and you don't understand divisibility, it'll make it a lot harder. So let's take a look here. It says, which of the following are factors of 42? Straight up, if you don't know the word factor here, you're going to be in trouble. So let's define it. So a factor is a number that divides another number perfectly with no remainder. And there's a few different ways to deal with factors. You could memorize all your times tables. Then you would know what divides another number perfectly with no remainders. But the deal is, we don't memorize all our times tables. You know, back in the day, they used to make students memorize up till 12 times 12. Now, more frequently, they make them memorize up till 10 times 10. And a lot of GED students don't have their times tables memorized at all. So, you know, what else could I do if it's not just have it memorized? Well, to see if something divides perfectly with no remainder, you could always try long division. So long division will work. And I'll use that for some of these numbers to see if they're factors. I'm going to test each one to see if it's a factor of 42. Okay? But another way, and the way I recommend, the way that I like best, is knowing your divisibility tricks. Turns out there's a few little tricks for some very common numbers that come up all the time. For example, the 2 times tables. If you think about the 2 times tables, 2, 4, 6, 8, 10, 12, 14, 16. The 2 times tables are just all the even numbers. And so I don't have to divide by 2 if I can just look at this number and ask myself, is it even? Well, notice that it ends in 2. If it ends in 2, 4, 6, 8, or 0, it must be even. So I know that 2 is a factor of 42. It will divide it perfectly. With no remainder. Now, could I go ahead and do the division to prove it to myself? I could. Of course, 2 goes into 4 twice, and it goes in perfectly with no remainder. And 2 goes into 2 once, perfectly with no remainder. And I see no remainder in this problem at all. And so, you know, whether I do it the long way or I know my divisibility trick, I know it's divisible by 2. Similarly, I know the divisibility trick for 3. It's known as a sum of digits trick, and it's one of the coolest tricks in my book. So if you don't know it, I suggest you Google sum of digits and check it out because it's brilliant. But what it basically says is if you add together the individual digits of a number, so for like 42, I'll add together 4 and 2, and you get a number on the 3 times tables, like 3, 6, 9, 12, the number itself is divisible by 2. Now I got a 6. 6 is on the 3 times table, so I know that 42 is also divisible by 3. Now, if you didn't believe me, let's say you didn't believe me, then your alternative is long division. You could divide 42 by 12 and see if you got a remainder. Or, I'm sorry, not by 12. You could divide 42 by 3. And see if you got a remainder. Let's check it out. 3 goes into 4 once. Now this time I do have a remainder, so I'll go ahead and subtract. 4 minus 3 gives me a remainder of 1. Drop down the next digit. And 3 goes into 12 perfectly 4 times. But that's exactly 12, so I end up with no remainder. See that? A 0 remainder. And so 3 is also a factor. Similarly to 2, 5s is another one that most students know the divisibility trick for. You guys are so used to the 5 times tables. 5, 10, 15, 20, and 25, 30, 35, 40. Those numbers are super, super easy to remember because they always end in 5 or 0. It's a nice pattern. Since 42 does not end in 5 or 0, I just know right from the start that it's not going to divide by 5. Now, once again, if you don't believe me, you don't have the divisibility tricks memorized, and I do have a whole series of videos on divisibility tricks. Long division is your only option, then you're going to have to divide. And you would see that 5 would go into 42 8 times, but I would end up with a remainder of 2. Look at that, a remainder. It didn't go in perfectly. It's not a factor. Okay, so 7 Now, here's one of the things about 7. I always tell my students, this is my warning about 7. 7 is the only one whose divisibility trick is so complex that I don't find it very useful. So if you're going to memorize any times tables, like say you're a student who has trouble memorizing, I always recommend that you try to memorize the 7s. I don't even care if you have any of your other times tables memorized. I can deal with it in all kinds of ways. But I would recognize a 7, so you know a 7 when you see one. So just counting by 7, 7, 14, 21, 28, 35. I can sure see that 42 is on my 7 times tables, meaning that if I divided 42 by 7, I'd get 1, 2, 3, 4, 5, 6. And so is 42 divisible by 7? It sure is. Now, 11 is another one that I think it's easy to tell if a number is divisible by 11. And again, it's because at least at first, the 11 times tables are very patterned. At least as long as they're 2-digit numbers, they are. If you think about every time you add 11, like if I were to add another 11 to 11, I'd go up by 1 in this column and 1 in that column, so I'd go to 2, 2. And then similarly, if I kept adding another 11, I'd go up to 3 and up to 3. Up to 4 and up to 4, up to 5 and up to 5, and so on. So when it's a 2-digit number, I can tell an 11 at a glance. That is not a double-digit repeating number. I don't see like 4 with 4 or 2 with 2. And so I can tell it's not divisible by 11. Now, if it wasn't a 2-digit number, if it was bigger, oh, I just said it wasn't divisible by 11, and I circled it anyway. Now, if it wasn't a 2-digit number, if it was a bigger number, like say if they were asking me if like a 362 is divisible by 11, well, then I might have to divide. 11 goes into 36. 3 times that'd be 33. I'd have 3 left over, drop a 2, and now I can see it's not divisible. I definitely have a remainder. So if it's 3 digits or more, use long division with 11. And again, I have a whole video on this. If it's 2 digits, though, you can spot an 11 with your divisibility tricks. Okay, great. If you have any questions about this, what is the correct answer? The correct answer is A, B, and D. All 42 is divisible by all those things. So if you have any questions about this or any other GED topic, be sure to drop it in the comments and I'll do my best to answer it.